Next up is the ellipse. One thing to remember about the ellipse is in your standard form that A is greater than B. And remember, no matter what, 2A is the length of the major axis. 2B is the length of the minor axis. And vertices of an ellipse fall on the major axis. And the co-vertices fall on the minor axis. So it all makes sense when we start looking at images of these, okay? Just make sure you have this written down. And remember that HK is the center. Okay. So after we have that written down, okay, there are going to be two types of ellipses, okay? When the major axis is horizontal, and then when the major axis is vertical. So remember, major means that's a longer one, so that means in this case the oval is going to be longer horizontally, the oval is going to be longer vertically. So if the major axis is horizontal, if it's longer horizontally, longer x, that means it looks like this. X minus h squared over a squared plus y minus k squared over b squared equals 1. Longer vertically, it's going to look like this. X minus h squared over b squared plus y minus k squared over a squared equals 1. Okay, so now I'm just going to give you an example. So an example would be x plus 1 squared over 4 plus y minus 3 squared over, actually let's make this bigger number. Make that 9, we'll make this 4, make this equal 1. So notice, if you just have this and you're told to graph, okay, the first thing, you know that this is an ellipse, because you have two quadratic terms, okay, it's plus sign, set equal to 1, and you have coefficients down here, I shouldn't say coefficients, sorry. You have values down here that are not the same value. That's how you know that you have an ellipse. Plus sign, square of binomial, set equal to 1, and these are different values, okay? So the first thing that I can pull from here is the center. So the center of this ellipse is what makes x 0, what makes this expression 0 for x, which is negative 1. Here's y, what makes this 3. So the center is going to be at negative 1, 3. Now, to figure out what's a and what's b, you take the square roots of these numbers as long as you're set equal to 1. The square root of 9 is 3. The square root of 4 is 2. Which is bigger? This number or this number? This number. That means a is 3 and b is 2. So a is 3 and b is 2. And now, where is a under? A is under x. That means that this is going to be longer horizontally because, okay, whatever you're under, okay, or I should say above, if you're above this, if you're above x, that means double this, and that's the length of the horizontal, because x opens horizontally. Double this, and that's the length of the vertical axis. Okay, so if I have to graph this, okay, well, I'll make this. Negative 1, 3 is the center, okay? So now, the entire major axis, which is going to be the horizontal, okay, x is going to be 6, double that. So what that means is I should go to the right 3, 1, 2, 3 units. I should go to the left 3, 1, 2, 3 units, okay? I should go up 2 units, 1, 2. I should go down 2 units. Now this, I didn't spread this out enough, these increments. So it looks like, okay, and so now I can make my shape. Now, that's called a vertex. That's called a vertex, okay? This right here, that's A, okay? This is also A. From the center to the vertex and to the other vertex is A, And that right there is B. That's the covertex. Okay? Down here, that's the covertex. Okay? The length of the minor axis is 2B. Okay? The center falls right in the middle of the minor axis and the major axis. Okay? So now, if we do this, okay, we'll do an example of this. If it's x plus 1 squared over 4 plus y minus 3 squared over 9 equals 1. Okay, this has the exact same center. The center is negative 1, comma 3. But notice, this time, this is 2, this is 3. So A is not under x, A is under y. That means it's going to be larger vertically. Okay, so A is 3 and B is 2, except A is under y this time. So when we sketch this, okay, negative 1, 3, that's the center. So now your vertices, okay, your major axis is the vertical axis. So that means your vertices are going to fall up and down. So you got to go up 3, 1, 2, 3. You got to go down 3 from the center, 1, 2, 3. Okay, this now has a length of 2A. Okay, now the minor axis, got to go to the right 2, got to go to the left 2. Okay, and this right here has a length of A, this has a length of B. Okay, this has a length of A, this has a length of B. That's called your vertex. That's called your vertex because your vertices, okay, that's the plural of vertex. Your vertices fall on the major axis, right? And this is the major axis right here. This is the minor axis, so this is a covertex. And this is a covertex. Okay, so if we notice, your vertices, okay, if you notice, if you are opening, okay, if your major axis is horizontal, okay, your y-coordinate is staying the same. It's just that the x-coordinate is changing by A. That point right there is just when you add A to the x-coordinate and don't change the y-coordinate. Okay, so it's going to be h plus A, comma k, and h minus A, comma k. Those are going to be the coordinates of the vertices. Your covertices, okay, this is when your major axis is horizontal. Your covertices here and here, that's the center HK. Notice your covertices are up and down with the vertex. So the x-coordinate isn't changing. So it's going to be h and then k plus b. And the other covertex is h comma k minus b. And here, it's very similar. Okay, your vertices, though, are lying up and down. So the x-coordinate stays the same, h from the center, and you add a, k, and then for the other vertex, you take away a from k. And the covertices, now the covertices, right, fall on the minor axis, and the minor axis here is the horizontal axis. So now your covertices fall left and right of your vertex. I'm sorry, of your center. So that's going to be h plus b, comma k, and h minus b, comma k. Okay, so those are going to be the vertices and the covertices. Okay, so we're going to learn about something called the foci, but before we do that, we're just going to practice graphing the ellipse twice. Okay. So we're going to graph each ellipse, and I'm going to give it to you already in standard form. Remember, if it was in general form, you're going to want to put it in standard form in order for you to graph. So number one, we're going to do x plus 2 squared plus, we'll say y minus 4 squared. We'll put this as 9, and we'll put this as 16. Okay, so here's our equation of our ellipse. We know that this is an ellipse because of the fact that, okay, we have two quadratic terms, and it's a positive here. It's set equal to 1, and these two numbers aren't the same. Okay, so what that means is if I was to multiply by something, okay, I wouldn't be able to get it to look like a circle where this was 1, and this was r squared. Okay, so we know this is an ellipse. So what we can pull out is, what's the center? So the center here is -2, 4. Now we have to figure out what A is and what B is. So we take the square roots of both of these. The square root of 9 is 3, and the square root of 16 is 4. Now which is the larger number? 4 is larger than 3. A is 4, B is 3. So I always write down what's the major axis. Well, 4, okay, the larger number is under Y, so that means the vertical axis is going to be the longer axis. So when I sketch this, okay, -2, 4, oh, made those too far apart. -2, 4, okay, so my vertices are going to fall up and down because the major axis is vertical, so I have to go up 4, so the center is -2, 4, so I have to go up 4, 1, 2, 3, 4, that's the point -2, 8, and down 4, 1, 2, 3, 4, that's the point -2, 0. Because I had to add 4, I had to add A and subtract A. Now your co-vertices fall horizontally with the center because the minor axis is the horizontal axis. So I have to go to the right 3, 1, 2, 3. So that's going to be the point 1, 4. And notice the Y stays the same, right? 1, 2, 3. Oh, notice, I made increments. I made them much larger out here. 1, 2, 3, still bigger. Too far apart. Okay, so there we go. And that point, take away 3 from -2, that's going to be -5, 4. And so there is our ellipse, number 2. If we had x minus 1 squared, let's say over 25 plus y minus 1 squared over 9 equals 1. Okay, we first identify, okay, yes, this is an ellipse. Okay, meets all the characteristics. So the center is 1, 1. Okay, find out which one's A, which one's B. Remember A, if this is an ellipse, A is just the bigger one. Okay, so take the square roots of both of these. The square root of 25 is 5. The square root of 9 is 3. So A is 5, B is 3. Now where is A under? That's going to be your major axis. A is under X, so that means this is going to be longer horizontally. Okay. So 1, 1's the center. So 1, 1 is the center. Now the major axis is horizontal, so our vertices will fall left and right because our major axis goes this way. So to the right by 5, 1, 2, 3, 4, 5. Okay, so that means that would be 6, 1. And the other vertex, I would take away 5, so that's going to be -4, 1. And your co-vertices fall on your minor axis. Your minor axis is up and down. Got to go up by 3. Got to go down by 3. So that's going to be 1, 4 and 1, -2. And so do your best to make that oval shape. Whoops. There you go. And so here is the graph of this ellipse. Now, sometimes these aren't going to be perfect squares. That's perfectly fine. That means these will just be decimals. That's okay. You can round. Okay, if this was the square root of, if this was 10 here and you had to write the square root of 10, you can just round whatever the square root of 10 is to 2 decimal places. Okay, it's not going to always be perfect squares there. Okay, so this is how we graph an ellipse. And so one more piece about the ellipse that I want to discuss before we practice one more graphing of an ellipse, and we need to talk about what's called the foci of an ellipse. So the foci are actually how you are going to be making the shape of an ellipse. So the foci, okay, these are 2 points that fall on the major axis of an ellipse. Oops. Okay, and so I'm going to show you, pretend that the major axis here is horizontal. Okay, hopefully my picture will indicate that. Okay, so there's the center. There's my ellipse. There's my best attempt at an ellipse. Okay, that's the vertex. That's the vertex. That's A. That's A. Okay, so your vertices, okay, are here and here. Your co-vertices would be here and here. The foci, okay, I'll call them F1, F of 1, and F of 2. They're going to fall on the major axis, okay? F1, F2. Now, they're both going to be equidistant from the center, okay? And these foci are actually how you are drawing an ellipse. So every single point that's on an ellipse, okay? Every single point that's on an ellipse, if I went like this, whoop, whoop, from the foci, and I added this distance, okay, this plus this, okay, if I added that up and I got the sum, okay, it would be the same as that plus that, and it would be the same as this plus this. And so all of these points that make up this ellipse are actually all of the points wherever the two foci are, okay, that when you add up those lengths are all equal, okay? So that's what the ellipse really is. So what you need to know is where to find the foci, okay? So to get, okay, the first thing is that this is the center, okay? We're going to call that length C. So to get length from center to a foci, one of the foci, so that's actually called a focal point if you just say one of them, okay? We'll call that length C, okay? So C squared actually equals A squared minus B squared, okay? Where A is the length of the, okay, from center out, and B is length from center to a co-vertex. And so if you want to get C, okay, you just take the square root, so you get A squared, the square root of A squared minus B squared. Okay, so if you take the square root of A squared minus B squared, you'll get the length of the focal point, to the focal point. So, if you need to name the coordinates of the foci, you just, okay, if the foci are going to fall horizontally, you add C to the x-coordinate and you subtract C to the x-coordinate from the vertex. Okay, so that's the foci, okay? Know to get the length from the center to a focal point, each focal point you do the square root of A squared minus B squared. This is the A and the B from the standard form of an ellipse. So we're going to do one problem now where we tie everything in about an ellipse. Okay, so we're going to tie in everything we know about an ellipse. Okay, so we're going to graph the ellipse. We're going to name it center. We're going to get the coordinates of the vertices, the co-vertices, and the foci. So if you look, we have to graph this thing. However, it's not in standard form. It's in general form. So the first thing we're going to want to do is put this thing in general form and then get it to standard form. It's very close to general form, sorry. So let's just check to make sure, yes, it is an ellipse. So 4x squared plus 9y squared minus 16x plus 18y minus 11 equals 0. General form, right? This is general form. We need to convert this to standard form. So we check. Okay, we have two quadratic terms, and they're the same sign, but they are not the same coefficient. So yes, this is an ellipse. So we gather the x's, Okay, we know we have to add a term there. Gather the y terms. We know we have to add in some term there. Bring this to the other side, so add 11 to both sides. And then whatever we add into the left, we need to make sure we add into the right. Now we have to complete the square twice here. Remember, can't start completing the square until this term has a coefficient of 1, so whatever it is, to factor it off, so 4. So now this becomes x squared, negative 16x would become minus 4x, and so now we can make a nice perfect square trinomial and complete the square inside here because the coefficient on x squared is 1. So half of this squared, okay, is negative 2 squared, 4. But I didn't really plug in 4, I plugged in 16. Okay, so now do the same. I can't start completing the square here because I need the coefficient here to be 1, not positive 9, so I factor out positive 9. Now I've got a coefficient of 1 on y squared, and this would be 2y, so I can make a perfect square trinomial in here. Half of this squared is 1, but I didn't really plug in 1, I plugged in 9, because 9 times 1, 9. Okay, so this is going to be 27 plus 9, 27 plus 9, 36. Okay, so now we can write this as a square of a binomial, and this is a square of a binomial. So that's going to be 4 times x minus 2 squared plus 9 times y plus 1 squared equals 36. What do we want our right-hand side to be set equal to in an ellipse? 1. So we divide that. So this is going to be x minus 2 squared over 9 plus y plus 1 squared over 4 equals 1. So now we can start pulling out information. Okay, we can pull out what the center is. So the center is going to be 2 comma negative 1. Okay, take the square root of 9. The square root of 9 is 3. Take the square root of 4. The square root of 4 is 2. So A is the larger one, so A is 3, B is 2. Which is the major axis? Where is A under? A is under x, so that means the horizontal is the major axis here. Okay, so now we can make a nice sketch. Remember, my increments are pretty inaccurate, so that could make this depiction of this ellipse pretty bad, because I could even make the illusion that it looks more like the major axis is vertical. 2, negative 1. Okay, so the major axis is horizontal, so I go 1, 2 to the right 3, and 1, 2, 3 to the left 3. So the vertices, okay, so the center is 2, negative 1, so the vertices are 5, negative 1, and negative 1, negative 1. Notice the length of the major axis is 6, okay, the length of the major axis is 6. Your co-vertices. So your co-vertices, okay, they're going to go up and down because the minor axis is vertical. So I've got to go up 2, and I've got to go down 2. So that's going to be 2 comma 1 and 2 comma negative 3. And so now I just make my shape. Now where are the foci falling? The foci, okay, the foci are falling on the major axis. Here's the major axis, okay? So the foci are falling somewhere on here. So to figure that out, where the foci are, okay, you need to first figure out the length from the center to the foci. Okay, so C equals the square root of A squared. Okay, A squared is 9 minus B squared. B squared, okay, is 4. So that's the square root of 5. So if I go to the right by 5, that's going to be one of them. And if I go to the left by the square root of 5, that's going to be the other one. So f of 1 is going to be to the right by the square root of 5. So that's going to be 2 plus the square root of 5, comma negative 1. And it's okay just to round that. You could do that. And the second focal point, okay, is going to be 2 minus the square root of 5. Okay? Remember, your foci always fall on the major axis. They fall equidistant from the center. And the length to a focal point is always going to be the square root of A squared minus B squared. Okay, so this is everything that we needed to answer and be able to do for an ellipse. Okay, so you need to be able to convert general form to standard form. You need to be able to pull out the center. okay, which is the major axis, which is the minor, be able to graph it, be able to identify the coordinates of the vertices, co-vertices, and also the coordinates of the foci. And that is it for the ellipse.